Hello friends, good morning. Myself, Dhaval S. Mistry. I am Assistant Professor in Mechanical Engineering Department in Mahatma Gandhi Institute of Technical Education and Research Center, which is situated in Navsari. Today we are going to discuss on a presentation on a types of casting process. Let's view first a casting process. All the metal may be cast in a sand mold and there is no limitation about the size of the casting which can be made. Casting having a wide application, however, sand mold are single purpose mold as they are completely destroyed after the casting has been removed from the molding box. The use of permanent mold casting would be a considerable saving a labor cost of molding making. Special casting methods are not commonly employed because of their initial cost. However, special casting methods have following advantages over a conventional casting. First, the greater dimensional accuracy, high production rate, however, production cost, better surface finish, denser and fine grained structure, greater dimensional accuracy, more ductile, and good quality. Let's view first a classification of casting process. The first one is permanent mold casting, second a pressure die casting, third one is cell mold casting, fourth one investment casting, then centrifugal casting and continuous casting. So let's we discuss about our first types of casting process is permanent mold casting. Here the two halves of mold are made of metal, usually cast iron, steel or refractory alloy. The cavity including the runner and gating system are machined into the mold have for following parts either permanent core made of metal or sand bonded ones may be used depend on whether the core can be extracted from the part without damage after casting. This casting also called a gravity die casting because the molten metal is poured into the mold under the gravity only. No external pressure is applied to force the liquid metal into the mold cavity. This casting is called a permanent mold casting because it is used the mold which is permanent. The mold can be reused many times before it is discarded or rebuilt. Permanent molds are made of grey cast iron having high resistance to thermal shocks, alloy steel for very high temperature and withstand surface erosion on non-ferrous alloys. Inner surface of the mold are coated first with the refractory and then with the lamp black or core oil. This is done in order to reduce the chilling effect on the cast metal and to facilitate the removal of casting and prevent the adhere of the molten metal to the mold. A permanent mold is made of a two halves in order to facilitate to removal of casting from the mold. Pouring cups, sprue, gates and riser are built in the mold half itself. The mold also have a facility of setting coarse injector pin and for injecting out a casting from the mold and clamp for clamping etc. For faster cooling fins and projection may be provided on the outside of the permanent mold. It is a permanent mold or gravity die casting. See in a figure there are gates, pouring basin, sprue, vertical parting line, metal core, casting, mold cavity, pouring basin and clamp and final is the casting produce. The advantages of the permanent mold casting is closer dimensional tolerance and accuracy, smoother surface and better appearance. Fine grained metal surface because of chilling effect. Mass production is more economical. Low overhead charges. Less labor work and time. Require a less skilled labor. Good quality of casting. Casting doesn't have any sand adhered to them. Require less space. Then disadvantages of a permanent mold cost much more than the sand mold. It is suitable for small and medium sized non ferrous casting only. Casting have poor elongation. Several defects like a stress and surface hardness may be produced due to the surface sealing effect. Since the gating system is cut in mold how on one's machine it cannot be changed. The extremely high temperature of the molten steel make this method unsuitable for steel casting. An application is carburetor body, refrigeration casting, oil pump bodies, connecting rod and automotive piston, typewriting segment, etc. This is the advantages, disadvantages and application of the permanent or gravity die casting. Next is pressure die casting. High pressure die casting is a process wherein the molten metal is forced under the pressure into a seal mold cavity. It is held in place by a powerful compressive power through die installed in a hydraulics machine until the metal solidifies. Following solidification, the die is released open, the metal is released. Unlike gravity die casting, in this molten metal is forced into a permanent mold cavity under the pressure. The pressure varies from 20 to 2000 kgf per centimeter per square and it is maintained till solidification stage is reached. The pressure is generally obtained by compressed air or hydraulically. Next, see in a figure, there are two types of process. First one is hot chamber process and second one is the cold chamber process. Let's we discuss about a first one is a hot chamber die casting. In a hot chamber die casting machine, the melting units in the machine itself, that is why is called a hot chamber die casting machine. The molten metal possesses normally about a superheater, therefore less pressure needed to force the liquid metal into a die. In this machine, a operated gooseneck container is operated by a lifting mechanism. Initially, it submerged in the molten metal and is filled by a gravity. Then it's released and bring the nozzle is contact with the die opening and is locked into the position. Compressed air then forces the normal into die pressure maintained till solidification. When its solidification is complete, the gooseneck is lowered down and casting removed by injector pins after the opening of die. It is a hot chamber process. Next is the cold chamber process. In this machine, the metal is melted separately in a furnace and transferred to them by a means of small hard ladle. After closing the die, the molten metal is forced into the die cavity by a hydraulically operated plunger and pressure is maintained till solidification. This machine can be either have a vertical plunger or horizontal plunger for forcing molten metal into die. These machines are widely used for casting a good number of aluminum alloy and brasses. This is the two types of hot chamber process and cold chamber process. Then the advantages of pressure die casting is it's require a less floor space. Die casting provide for a precision manufacturing with substitute reduction in machining cost. Thin section of complex shape are possible 0.4 mm, high production rate, greater surface finish, insert can be easily cast in a place. Die casting are less defective than sand casting. The increased soundness and reduction of defect provide increasing yield. The labor cost involved is less. Thread or other fine surface detail can be easily obtained. Then limitation of die casting is the cost of die equipment is high. The life of die decrease rapidly in metal temperature is high. Ferrous alloy are not cast and moreover a limit number of non-ferrous alloy can be economically die cast. The size of casting is limit. The air in the die cast gets trapped inside the casting and creates porosity. Special skill is required for maintenance and the supervision of die. Application of the die casting is Die casting process has been used of many non-ferrous metal and alloys such as zinc, aluminum, copper, manganese, lead and tin. Automobile parts, marine use, domestic application, instruments, parts of the refrigerator, washing machine, television, typewriter, projector, radio, binocular and camera. These are the application of a die casting process. Next is centrifugal casting. In centrifugal casting, the centrifugal force play a major role in shaping and feeding of the casting. In this process, mold is rotated rapidly about its center axis as the metal is poured into it. Centrifugal casting uses a permanent mold that is rotates about its axis at the speed between 300 to 3000 rpm as the molten metal is poured. Centrifugal force causes the metal to push out toward the mold walls where it solidifies after the cooling. In this process, the casting is made in a hollow cylindrical mold rotate about an axis common to both casting and mold. This axis may be horizontal, vertical, or inclined. The casting have a more or less symmetrical configuration, round, square, hexagonal of their outer contour and don't need any central core. Casting cools and solidified from the outside towards the axis of rotation, so its result in a good directional solidification. Hence, casting are free from shrinkage. True centrifugal casting may be produced in a metal or sand line mold depending largely upon the quantity desired. The advantages of a centrifugal casting: there is no need of core to make pipe of a tube. The no gates or riser are used, so no material is waste. Proper direction solidification is above obtained. Dense the fine grain metal casting. It is a quick and economical method. The impurities segregate toward the center from where they can be easily machined. See in a figure the mold, molten metal, spout, ladle, roller, and drive shaft. The disadvantages of centrifugal casting: it is limited to symmetrical shape objects such as pipe, roll, cylindrical, etc. Equipment costs are high. Skilled workers are required. Application of this centrifugal casting is liner or IC engines, pipe, roll, cylindrical sleeve, piston ring stock, bearing and bushing, etc. It is the centrifugal casting. Next is the cell mold casting. A cell mold casting yield a better surface finish, quality and tolerance. The process is desired as follows. The first two piece pattern is made of metal, aluminum or steel. It is a heat to between 175 degree to 370 degree and coated with the lubricant silicone spray. See in a figure there are different types of cell molding casting step. The in this process is which the sand mixed with the thermosetting resins is allowed to come into contact with the heated metal pattern plate so that a thin and strong cell of mold is formed around the pattern. Then the cell mold is removed from the pattern and the cope and rag are removed together and kept in a flex with the necessary backup material. After that, the molten metal is poured into the mold. There are different types of step. First one is a pattern rotate and clamp to a dump box. Then a pattern and dump box are rotated. Then pattern dump box is position of the for the investment. Then pattern and cell removed from the dump box, and let's see final figure for the molten metal are poured into good cell house. Okay, then a metal pattern heat about 175 degree to 350 degrees clamp over a box contains sand mixed with a thermosetting resin such as the phenyl formaldehyde, urea formaldehyde or polystyrene. The box and pattern are inverted for a short time. The mixer when the comes in contact with the hot pattern is caused an initial set and build up a coherent and sand cell next to the pattern. The thickness of the cell is about 6 mm to 18 mm and is dependent on the pattern temperature and sand mixer. Time taken to 5 to 20 seconds only. The box and pattern are brought into the original position. The cell or resin bonded sand is retained on the pattern surface while unaffected sand falls into box. The cell still on the pattern is cured by heated in an oven from 250 degree to 350 degree for 1 to 3 minutes. The assembly is removed from the oven and the cell is stripped from the pattern by injector pin in order to obtain clean stripping. A silicone parting agent may be sprayed on the pattern. The cell how are assembled with the clamp and supported in a flask with baking material. The cell mold now ready for pouring. It is the cell mold casting. The advantages of cell mold casting is suitable for a thin section. Surface finish obtained in excellent, good dimensional accuracy, less floor space. It can be easily machined. Machining and cleaning cost is negligible. The total sand use is only 5 to 10. That is green sand mold. The mold can be stored until required. Disadvantages of cell mold. Initial cost of pattern and sand is high. Special equipment are to be used. The use of sand is difficult. Maximum size of casting is limited. Minimum thickness of the section that can be cast in is 4 mm. Certain casting shapes are unsuitable when proper parting and gating is not available. This is the disadvantages of cell mold. Then the application of cell molding, it is well suited to ferrous and non-ferrous alloy casting in the range of 0.1 to 10 kg. Alloy that can be cast by cell mold are aluminum alloy, copper alloy, cast iron, stainless steel, etc. Component cast by cell molding are small pipe, camshaft, bushing, valve body, spares, brackets, bearing caps, shaft and gears, automotive rocker arm and valve, etc. Next is investment casting. In this casting process, a pattern made of a wax is coated with the refractory material to make the mold surface, after which the wax is melted away while pouring the molten metal. Investment means to cover completely, which is referred to the coating of the refractory material around the wax pattern. This is precision casting process. Using this we can make a casting a high accuracy within intricate details. This process is use a wax pattern which is separately melted from the mold, leaving a cavity having the all details of original pattern require a casting. There are different types of step. For first one is the wax pattern or poured mold, injector mold. Then the multiple pattern are assembled to a central wax sprue. A cell is pulled by immersing the assembly in a liquid ceramic slurry and then into a bed. Extremely fine sand, several layers can be required. The ceramic is dried, the wax is melted out, ceramic is fired or to burn all waxes. The cell is filled with the molten metal by gravity pouring. On solidification, the parts get through and pouring cap become one solid casting. Hollow casting can be made by pouring out excess metal before it solidifies. After metal solidifies, the ceramic cell is broken off by vibration of water blasting. The parts are cut away from the sprue using high speed friction, so minor finishing gives final parts. The first step we discuss about producing a die for making a wax pattern. Let's we discuss about in details. The first step, dies may be made either by machining cavity in two or more matching block of steel or by casting a low melting point alloy around a master pattern. Die halves are then sent for necessary machining and drills the gates through which wax is to be injected for preparing assemble pattern wax plastic thin frozen mercury in mustard for but the wax is more commonly used. Then making a wax pattern. The die halves are closed and properly clamped. Molten wax is then forced into a die under the pressure by means of wax injection machine, allow cooling and solidification. The die is then opened and the pattern is removed. A lubricant is then sprayed on the die surface and same is closed for casting the next wax pattern. Third, then the assembling the wax pattern. Assembling a number of small wax pattern to common wax gating system so that they can be placed together in one mold. Next is the pre-coating the pattern assembly. The wax pattern assembly is dipped into a slurry of a refractory coating material. A typical slurry consists of 325 mesh silica floor suspended into ethyl silicate solution. Wax pattern assembly in a rack sprinkled with the 40 to 50 fs American Foundry Society silica sand and the permitted to dry. Then next step is investing the wax pattern assembly for the producing the mold. This is done by inverting the wax assembly of on the water board surrounding it with a paper line, steel flags and pouring in the investment molding mixer around the pattern. The mold material settle by a gravity and completely surround the pattern as the work table is vibrate. The mold are then allowed to dry in air for 2 to 3 hours. Next step is removal of wax pattern. The wax pattern can be removed from the mold by a two method. First one is placed by a mold of furnace in an inverted position. Screw downward, the wax is melted out due to the heat and collected for reuse. In other method, mold is placed in a bath, typically a vapor, which is also enable the recovery of wax for reuse. Next step is pouring and casting. The mold is again heated at the rate 40 to 70 degree per hour from the about 150 degree Celsius to 1000 degree Celsius ferrous alloy and 650 degree alloys, aluminum alloys. Preheating is done the remove of wax if any. It helps the metal to flow easily and fill up properly. It causes a expansion of the mold. After preheating, the metal is poured into the investment mold under the simple gravitational force of under the force of applied air pressure or by centrifugal force. Then last step is cleaning, finishing and inspection. Each casting is separate from the assembly and gates, runner, etc. are removed. Finishing and inspection of casting is done. This is the for the investment casting. Then last one is the process of continuous casting. In the continuous casting, also a referred or straight casting is a process and used in a manufacturing industry to cast a continuous length of metal molten is cast through a mold. The casting takes the two-dimensional profile of the mold, but its length is intermediate. In this process, the molten metal is continuously poured into the mold, around which there are facility for rapidly chilling the melton of the point of solidification. The solidification metal is continuously removed from the mold at the calculated rate. In this process, the metal is fed by gravity into the mold and withdrawal by the roller below. See in a figure vertical continuous casting, the layer molten metal, then water cooled mold, secondary cooling zone, and then last one is the withdrawing unit. The die is water cooled and itself lubrication. The upper end of die is a molten metal and thus serves a function of riser. A show is provided below the roll to cut a product to desired length, and oxyacetylene cutting is done. Argon is added with the molten metal to avoid the atmospheric contamination. Then advantages of a continuous casting is 100% casting is 0% wasted. The process is cheaper than rolling. Casting surface are better. Grain size and structure of the casting can be easily controlled. The process can be easily mechanism and thus until labor cost is less. The application of the continuous casting is materials such as brass, zinc, copper, aluminum and its alloy magnesium, carbon and alloys etc. Production of bloom, billet, slab, sheet, copper bar etc. It can be produced any shapes of uniform cross section such as rectangle, square, hexagonal etc. This is the continuous casting process. In this video we are covered mainly 6 types of casting process. It is very important to ask in a GTU exam in 7 marks. Thank you.